Hello kids, today I will be reviewing another unique topic. It's a miscellaneous topic. This is called unit conversions. Today I will be providing you some key conversion systems in which you can convert the most common, you can say, units that are being used in numerical values, so that you're able to resolve different questions very easily. So what is unit conversion? It is actually converting from a higher to a lower unit. So I'm just going to lay down this basic rule. Let's say if you want to get to a lower unit, right, uh, to a higher unit, right? So remember that you have to divide, and when you get from higher to a lower unit, then the rule is that you multiply that whatever the multiplier is there, right? So let's go for length, right? And we do know the SI unit for length is meters, right? So I'm just going to draw meter in the middle, right? Since I'm going to make a very big diagram, so let's put meter in the middle. And we do know from meter, we can go to centimeters, right? And then we also have millimeters, right? These are very close to one another. So from meter to centimeter, now meter is a higher unit and centimeter is a smaller unit, so I'm going to multiply by 100, as centi means 100, so it means 100th part. And from meter to when we go to millimeter, we're going to multiply with 1000. Milli means 1000, right? And same way, between centimeter to millimeter, we multiply with just 10, which again makes it 1000 as a whole. So you understand now for why from milli to meter and from meter to milli we have this thousandth of a multiplier. Same way, from millimeter to centimeter, we actually divide by 10, as we're going from smaller to higher. And similar way, if we go from centimeter to meters, we divide it by 100, right? uh, and as a whole, we're going to get this larger one, which is going to be divided by 1000, right? So this is one. And from millimeter, we actually have, I told you, micrometers, right? That's a smaller unit, so we go here again, we divide it by sorry, we multiply this by 1000 if we're going down, and if we come back up, then we have to divide it by 1000, right? So that is going to be how this conversion is going to work. Similar way, if we want to go into the bigger units, we have kilometers, right? Usually these are the main common units which are being used. I'm not going to go and draw a bigger map. So when we go from meters to kilometers, we need to understand, we need to divide the value by 1000, right? So this is how the conversion is going to be. And when we come back from kilometers into meters, the value, whatever the value you have, it should be multiplication, right? So we need to multiply it with 1000, right? Okay, moving on. This is for length, and the second most important unit that we use is actually mass. So we are going to work with mass. Mass is actually the SI unit. SI unit is kilograms, right? And this already has a prefix to it, which is kilo. So keep that in mind. When we're working with mass, we keep that in check, that we're working with kilograms. So let's put kilograms in the middle. Imagine this is, remember, this is a small k, right? It's not a capital K. And we can go to grams, and then we can go to we can go to milligrams, and then into micrograms, right? So I'm just going to write milligrams, and then we have micrograms, right? And similar way, we have kilograms, and then we've got tons, right? So we do know, let's say if we have 1 kilogram and we want to go from this to this, so I'm just going to draw these arrows all the way, so that I don't have to work this, and I'm just going to write the numbers in a faster go, how these unit conversions work, right? And similar way, from kilograms to tons, and from tons to kilogram. These are the most common units which are used in your exams. So we're going to stick to just these numbers and not going to go in deeper into more of these, right? So from tons, we do know 1 ton is actually thousands of kilograms. So we're going to multiply with 1,000. And then if we take 1 kilogram and convert into grams, we've got 1,000 grams, right? So 1 gram has 1,000 milligrams, and then from 1 milligram to microgram, we've got 1,000 micrograms in 1 gram, right? Similar way, if we divide it down, so we will come to divide it by 1,000. If we're going up, same again, divided by 1,000, again division by 1,000, and similarly again divided by 1,000, right? So this is how we convert the units for mass. Last, we've got time, right? And I'm just going to convert just 4 base quantities, not more than that. I'm not going to convert all 7 of them because only 4 of these are important, in which length, mass and time are the most important. Temperature is used only for the thermal block, right? So rest of these 3 base quantities, length, mass and time, are used for all nearly 5 blocks, including the 6th, which is the space block, right? So we can say that all of the physics will actually use these 3 base units as a whole, and temperature will mostly be used for the thermal block. So these 3 are really important. So time, the SI unit is seconds, right? So let's go with the second, right? And this actually is a bit odd, unlike others. So we have second in the middle, right? We have milliseconds, then we have microseconds. But for the let me just clarify the space, because I'll be needing space on the right hand side. So let's go with microseconds, then we have milliseconds, then we have seconds, and then we have minutes. Now this is a bit different compared to the other ones, which are multiples of 1,000. This is actually a bit different, right? And then we have hours, right? This is the unit that you can write. And then we have days, and then we have years, right? So if you go from years into days, we do know 1 year has 365, right? And 1 day has 24 hours, and then 1 hour has 60 minutes, right? And 1 minute actually has 60 seconds. And from here on, it is again a multiple of 1,000, because now we have prefixes over here, which is the milli and this micro, right? So that's the only difference, that these bigger units are different. Rest are again same. If you go to nanoseconds, then again it would be a multiple of 1,000. The way back up, it is going to be same over here. It is going to be divided by 1,000. From milliseconds to seconds, it is again going to be a division of 1,000. But from second to minute, this is going to be divided by 60 to get minutes. If you have seconds, certain value for seconds of time, you can convert it into minutes by dividing by 60. If you have minutes, you divide it by 60 again to get hours, and then you can convert hours into days by dividing it by 24. Remember, whatever the multiple you used for multiplication should be the same for a division. That does not change. The number remains the same, right? And from days to years, you need to divide the number of days, right? The same way you converted that, right? So ahead of years, we don't count that much for physics, at least. This is the biggest unit we get. So these are actually much bigger units. So these are the 3 most common, you can say, conversion that you will be using, right, for any case. So let's move forward, which is the last one that I'll be reviewing for this unit conversion, is actually temperature, right? So I'm just going to clear my space a little bit. So temperature. So temperature, the SI unit is Kelvin, right? So this is a bit odd of a conversion. So when we go from now we do know we have only three basic units, which is the degree Celsius, right, degree Fahrenheit, and Kelvin, right? So from Kelvin, if you want to go from Kelvin to Kelvin to Celsius, this is kind of different as compared to these are formulas that you need to understand. You have any so degree Celsius is going to be Kelvin plus 273, right? And from Celsius to Kelvin, it is going to be uh, Kelvin is equal to degree Celsius minus 273, as you can simply take this value around and get Kelvin out, right? So this is for Kelvin, and then we have uh, Celsius to Fahrenheit, right? Degree Fahrenheit. So let me just get it. So it would be degree Fahrenheit equal to degree Celsius into 9 by 5 plus 32, right? And the other way around, if you want to get degree Fahrenheit to degree Celsius, right, then it's the other way around. Degree Celsius is going to be, now you need to understand this numeral over here. It is going to be degree Fahrenheit minus 32, right? And it would be furthermore, since we have subtracted this, it would be multiplied by 5 divided by 9, right? So this is how it's going to work for you. This is how you convert these values, and these are the four most common, you can say, conversions that you will be needing for each of these. I'm just going to draw these lines so that you don't mix these parts in case if you're reviewing from this notebook, to clarify this, that these are different sections of the page that we will be reviewing. Now I can give you certain examples. We'll be doing certain examples for this, for unit conversion, right? So that's mass, time, and then finally we have temperature. We will do these examples. You can do these examples on your own, and if you get any trouble doing so, you can also post me a question. I can share my value of what the conversion is supposed to be. So let's do some practice questions, right? So let's call it practice time, right? Practice questions or conversions, right? So let's say we've got 20 centimeters. So from this to SI, it would be 20 centimeter multiplied by 100. Sorry, it should be, since we're dividing it, I forgot we're going to higher. So we will again now divide this by 100, and we get 0.2 meters, right? Now I will tell you the process with which I convert. This is what I actually do. So before I go into conversion, let's just forget about the practice question for the moment. Let me give you my method of conversion, in which it's a foolproof methodology. Let's say if you have larger unit, let's say if you're converting derived quantities, right? So let's say you want to convert speed, right? What about speed? Speed is not a base quantity. These were four base quantities, and we do know the SI unit for speed is meter per second, right? But what if you have like 20 kilometer, or let's say we have you know 36 kilometer per hour. Now these are not SI units, right? So to convert this into SI units, I will make a conversion chart. 36, I'm going to draw this vertical line. I'm going to write the units which are in the positive power, which is kilometer, and the negative ones underneath r, so that this is justified. Now remember, I will independently convert these. I do know to divide this, to remove this, I need to divide it with kilometer. So I do know this is 1 kilometer. So 1 kilometer is crossed out here, but 1 kilometer is equal to thousandth of a meter. So this is how it will go. So now we have converted kilometers into meters while dividing this value, and the multiple is already there on its own, right? And for hours, I need to divide it by 1 hour, so that r is disturbed, but 1 hour is equal to 60 minutes, but I need to get to seconds. So again, I will convert minutes into seconds. So it would be 1 minute having 60 seconds. So minute is also crossed off. So now I just need to go through this, that I will simply take all the numbers, right, from here in the next step. What do I get over here? I will take all the numbers together. So what is the remnant of this? It is actually going to be like this. So it would be 36 multiplied by 1000 meters. The unit meter is left over here, and divided by 1 into 60 into 60. So it is going to be 60. I'm not going to write the 1 into 60, and the remaining unit that we have left with is seconds, right? So this will actually result in this 0 cancelled, this 0 cancelled, and 36 and 6 ones are, so this gives you actually uh, 1 into 10 gives you 10 meter per second. So yes, we will simply say that 36 kilometer per hour is equal to 10 meter per second, right? And this is how I do complex problems, right, in terms of derived units, right? I just gave you one example. You can convert others as well. Let's say if you're using other units like acceleration and stuff, but mostly acceleration is given meter per second. The most troubling unit is actually speed, which is given in kilometer per hour or centimeters per second. So you can convert it into SI units using this kind of a conversion table process. If you still need some clarity, let's do another example for speed, because I think this is a method which is rarely taught in classrooms. It's a very unique method of converting units, but as I said, it's foolproof method. Let's just say we want to convert meter per second into kilometers per hour, right? So let's say we have 70 sorry, we've got a speed value 20 meter per second, and to be converted into kilometer per hour, right? So how am I going to do that? Again, I'm going to draw this chart. It would be 20 meters divided by the unit that is a negative value, right? So that it is 20 meter per second, right, over here, per second. Second comes at the bottom. To convert this second into first we'll convert the ones on the top. So to convert meters into kilometers, so I need to understand that I need to have meters at bottom, but to go into kilometers, I will go with 1 kilometer here. Again, the same conversion, except now it is upside down. So meters cancelled, so we've got kilometer left, right? So that's done. Now for seconds, to go into hours, we will go with this, that 1 second needs 1 minute will provide us 60 seconds. So second is crossed off, so we get minutes. Now to convert minute into hours, we get 60 minutes in 1 hour, right? So again, minutes are cancelled off. So the summed up value will be again written as simply as this, that it is 20 into 60 into 60 divided by 1000, right? And the units that we're left with are kilometers on the top and hours in the bottom, right? So whatever unit is asked for, like let's say kilometers per minute is the unit that is required. You can stop right here and forget about this part. But now I suppose you'll be able to do these conversion very easily, more frequently. So this is what you get, right? All zeros are cancelled off. Now you have left with 2 into 6 into 6 kilometer per hour, which is actually would be 72 kilometers per hour, right? So this is how you can convert these troubling units for speed without any error. This method, if you adapt to this, it is going to help you, convert these very easily. So again, now time for practice questions. So let's do some practice questions, right? Uh, uh, Convert 20 centimeter into meters, right? Uh, that would be, you can use the same method, right? 20 centimeters, we don't have anything at the bottom, so we need centimeters at the bottom and meters on the top. We know 1 meter has 100 centimeters, so we cancel off, and this is what we get. We get 20 divided by 100 meters, so again it would be 0.2 meters, right? So you can use this chart, but again, that this would actually slow you down for these smaller units, singular units. If you have complex units like speed or acceleration, you can do this chart method. I actually use this conversions. I've memorized these conversions. Let's say we've got 24 micrometers, right? So from 24 micrometers, I need to understand, I need to go from 24 micrometers, right? Let's just make a chart to reinforce the chart method, right? I do know 1 millimeter actually has 1000 micrometers. Remember, you have to cancel these, so you will automatically put the same units at the in the opposite location. If it's on the it's on the numerator, then the other one should be a denominator to cancel it out, and the conversion should be there. And since I want to go into meters, so I will again convert millimeters. I do know millimeter is going to come here, so I know 1 meter actually has 1000 millimeters, so I cancel it off. So we now are in millimeters, sorry, in meters. So this is actually now simply 24 into 1 into 1 divided by 1000 and 1000. So this is going to be, you can say, now again it is going to be 0.12 and 40. 1 2 3 4 2 4 meters, and this is not correct. And why this is not correct? It's not the numerical value which is incorrect, it is the method with which I wrote this number. If you remember the scientific notation, I need to have first non-decimal, so it is going 1 2 3 4 5, so it is going to be 10 to power minus 5 meters. Now that is correct way to write. As I said, the numerical value was correct, but we need to understand scientific notation, right? So keep that in mind. Scientific notation is very much important when you're writing answers. I hope I've clarified the unit conversion to you. You can review these notes whenever possible. For temperature, we can do several examples. You can take any value, convert it out, and do these conversions. If you have any queries, just let me know, and we'll I'll respond as quickly as possible with the answers. Thank you for your time. Bye bye.